Okay, we will start soon, in a few minutes. Basic programming, that's fine. View, present. I think we can start. Okay, so the lesson 3, the purpose of lesson 3 is to finally get introduced into object-oriented programming and familiarize yourselves with what a class is and what OP is all about. So OP is essentially a bunch of functions inside an object. And hello, average guy. So it's a bunch of functions inside an object. It's not a bunch of variables inside an object, because if it was just that, then we would be having essentially the same as we have with functional programming, which also operates with functions to data. But with OP, we wrap both um, into an object, and we expose behavior and data through functions. So objects hold functions, and that's the key point of OP, to, to hold a bunch of functions. So why do we need OP and how does it help us? First of all, um, like I said, FP, functional programming, works with functions directly. It doesn't have a mutable state. It has a mutable state, and it works strictly through input and output, and there is nothing in between. There is no state. There's just variables and functions. With OP, we have abstracts. We abstract away our access to data through objects. We encapsulate it. So it keeps the data safe, and it exposes only the needed, uh, the most needed, not all the needed functionality of our class. It hides details, and it uh, rids us of the trouble of having to know what happens under the hood in every class. We simply communicate through the methods which the class exposes publicly. So there are 4 principles that object-oriented programming has. It's encapsulation, abstraction, inheritance, and polymorphism. Those principles are a key for every program which you write based on OP. So today I will try to cover in detail 2 principles, which is encapsulation and abstraction. I will mention inheritance and polymorphism, but I won't go into detail about it because it will be a topic of the next lesson. So what is encapsulation? It's hiding details. Those details are 2 things, actually 1 thing. Those details are our data. We don't expose our data directly. We expose it through functions, and those functions in C# are called properties. Well, in general, in every language, the functions through which you expose your data is called a property. So to get data, to set data, to manipulate it in any way, we use a property, a method to set or get data. And this is why, because we don't want to expose our private information publicly, because it is something that we shouldn't touch directly, and we should expose through some sort of a method. Also, another point why we want encapsulation, because sometimes when we set or get something, we might have um, uh, more than just setting or getting a value. And the third thing is that we sometimes want to limit access for a specific operation. For example, we might want to only get data, like have a read-only data, but privately we might inside a class still set it. So we might want to restrict access for setting and getting explicitly. With a field, we could make it either exposed publicly or not. So with properties, we can do both, reading and writing separately. Abstraction in OP essentially is working with concepts rather than details. When we have a class, it can have 1,000 methods. Of course, it won't have 1,000 methods, but it could be, all those 1,000 methods could be exposed through a single public method. We don't care about private details, we care about public. Public is accessible to us, and that's called abstraction. We don't know all the details, and we don't have to, as long as we understand the concept of how a class, a method, and properties inside it are supposed to be used. So having just enough info about a class is called an abstraction, and it's a very useful principle in OP. So the other two principles is inheritance, which is inheriting data from a parent class and a child class, which is forming and is a relationship between the two, which is creating a dependency on the parent. But this will be covered more in detail in the next lesson. And the fourth principle is polymorphism. It's when one object acts as if it was another one because it has a hierarchical relationship to that object, and essentially it is a variant of that object, some kind of that object. It is not that object directly, but it is an abstraction of it, more like an implementation of it, an addition of it. So either of those. So that's polymorphism, and you can call and store and work with different classes as if they're one, as long as they are related through either an interface or inheritance. So those are the principles, and the other two will be covered in the next lesson. So let's start with a class. What is a class? Simply put, it's a blueprint for making objects. Instance of a class is called an object. Variable in a class is called a field, and a method through which you access a field is called a property. So we use classes to create objects, and object is an instance of a class. So let's move on. And you define a class with a class keyword. So first you write an access modifier, then you put a keyword class, and then you name it. And that's how you define a class. Then you open a scope and write whatever you want within it. So I said that we don't expose fields publicly. We have our fields private. It's data. It's not supposed to be tampered with directly. It's supposed to be tampered with through properties, through methods, as long as... So internally we will work with it through fields, and externally through properties. Right. Let's move on. And so in general, a property is just a method. A method to work with fields inside our classes. In this case, In this example, the topmost example, we have old school string field, which is which can be retrieved through a get method, get old school. So get old school will simply return old school, and that is called a property. In C#, however, unlike in other languages that I know, we have a get and set keywords, and with those keywords we can we no longer need to write a method explicitly, and we can use a get and set keyword to define a property, to implement it without the need of writing a full method definition. So in the second example, we have a private string name and public string name capitalized, and inside of it, it's a property. So this property has a single method, single get method, and through that method we return a name. The third example shows an expression-bodied getter which gets a mana cost. And now to sum the three properties that we defined, I can say that all of those could have been written easier. So if you look at the description example, we have private set and get. By default, get will be public. I mean, by default, if you don't put access modifier, a property access modifier will be a get. Will be a public. Sorry. So in the fourth and fifth example, we no longer write a full implementation of a getter and setter. We just write set and get. And what it does under the hood is what we have in the examples above. It will create some private field, and our property will simply return or set a value for it. So that is a property. And now a method. In general, a macro basically is something that stores a bunch of instructions for a computer to execute. And a function could be called a macro, but a function which is inside an object in a class is called a method. So in C#, since everything is accessed through a class or a method or an object, every function in C# is a method. So we have an example. We have a spell. Inside a spell class, we have apply method, which takes a target and applies damage to a target. And target, you see the implementation of take damage method. This is an example of abstraction because you now no longer need to know what to do when target takes damage. You simply call a method take damage, which reduces the hit points by some damage amount, and if hit points is under 0, the target dies. And we have a constructor. The last most important thing about class is to know how can we build an object from it. How does a class construct an object? So it constructs an object through a constructor. A constructor will be called with a new keyword. So I'll say new damage spell, and I'll say, let's say name will be fireball, description will be amazing spell, mana will be 10, and damage will be 5. And this is the minimum information which is needed for a spell, a damage spell to be built, to be created and instantiated. And that data will be passed through a constructor, and the fields will have the value set as we pass in constructor. Okay, so this is the example of implementation of a damage spell and a target classes. I will move back to this example a bit later when I cover all the theory. how we work with it. And let's move on to the last thing I wanted to mention, and that is static. Uh, to put static in a nutshell, it's basically one for all. And since it's one for all, you cannot create instances of it. It's a single method, a single property, a single field, a single class through the whole application, and it will stay alive through the entire runtime. As long as your program is alive, the static will remain. So it will not have an instance. And that's why you no longer need to create an object to access something that a static contains. A static class can be accessed directly. So in this example, you see we have a static class and a static method log, and when a player dies, a target dies, we log a message that the target is dead. So we didn't have to create a logger instance. We could access log method directly through a class. And that's what static is all about. Let me check. Okay. So to go back to static, we shouldn't abuse it. Because static is a global state, and to manage a global state, it's difficult. It's difficult because it can change from anywhere in your program, and it is, of course, it's easy to use static, but it's also easy to mess it up quite fast. Another thing, but on the other hand, static could be useful when you want to have helper methods. When your class has no context, in other words, when your class has no fields and contains only methods, it's not a bad thing to have a static class with static methods. Why not? Because there is no context. Because a great example is calculator. You don't need to create an instance of a calculator, because all you have to do is to pass let's say two numbers and an operand, and it will give you an output. There is no context in between, there is no state. Of course you could track history, but that would still mean there is a single calculator with a single history, and that's all. A problem would be is when you have a calculator and you only use calculator in a very specific place of your application. If your application itself is a calculator, then it's no problem, but if there's like a tiny section in it which just does calculations, then static becomes a problem, because you waste memory and because you unnecessarily expose it, because it will only be used in a single place, and the global state is just something that you should avoid. That's about it. And now let me demonstrate how you can use this. Let me split these into different locations, into different files. So in the examples I showed a spell, a target, and a caster. So a caster, a spell, a damage spell, is something that a caster can use, and a caster has a spellbook, which is a collection, a list of damage spells. And when a spellcaster casts a spell, because a spell cannot be casted by itself, like a spell should not cast itself, there should be something which casts it, you decrement the mana of a spellcaster and you apply some effect to target. Alright, so I have my game core and caster, damage spell, target, and I will open my console and we can do some testing. I'll delete this as it's no longer necessary. I'll move this to also different files as it's not necessary, and let's test it. So I would like to create a caster, and I cannot create a caster because I need to add a reference to my innershapemage.game.core. So I create a caster, and a thing to note here, a caster has a default constructor without parameters. If I would remove this, and if you go back, you still see that caster can still be created with a constructor which has no parameters, but then there is no constructor. So by default, caster, by default, a class has an empty constructor. As soon as you write your own constructor, let's say with parameters, without parameters, the default constructor gets rid of or is inaccessible because you wrote your own. For example, if for a person to exist, you need to provide a name and age, and you define that in a constructor, you should not be able to create a person through without providing the two. And that's why exposing the default constructor for a person would be useless. So we have a caster, and we can create a caster. We can now create spells. Spell 1. Actually, I'll just call it meaningfully. We have a fireball. So new damage spell, fireball. Description, AoE damage. Mana cost 10, damage 5. And another one, Scorching Ray. Scorching Ray. Description, AoE damage as well, let's say. Mana 10, damage 10. And last one will be, for example, Death Touch. So it's a damage spell which has a name Death Touch. Description, single target damage. And mana cost 5, damage 2. And one thing that I forgot, we have a spellbook in our caster, but we have no way of adding spells to the spellbook. So we should have added a method. So we now abstract away the spellbook part. We no longer care if it's a list, if it's a dictionary or whatever. We simply have a way of adding a spell. And now I'll actually change this to dictionary a bit later to see why. So we have a method. We need a method to add a spell to a spellbook. So we will add a spell to a spellbook. So we can do this. And now if we go back, we can say caster.addSpell, and we can add all of those spells. I'll make this a bit more fancy, and this, what I do now, is called a builder pattern. What this lets me do essentially is to stack methods like this. So I have a caster, I add spell again, so I no longer need to write caster, add spell, like separately. I can write it without rewriting caster again and again. So it's like slightly more convenient. I'll put it like, I actually don't know if, I think this is fine. So actually the best way, the most pretty clean way to do it would be like this. So I created a caster and I added 3 spells to it. And now if I do this cast, I need to pass a spell, a target first, so I'll create a dummy target, var dummy target with HP of 10. And cast. So now cast makes no sense, because now when I cast, I use those spells, and I should not know about those spells because I already have them in my spell book. I could expose them through a key. If I could provide a key, somehow I could cast a spell, because now I would need to guess which spell is which. And for that reason, it's quite nice to have a dictionary and spells by name. Later on this will be refactored, but now it's fine. So fireball, spells, spell, fireball, scorching ray, and death touch. Alright, spell name, maybe. It's enum because I don't want to mess it up. I don't want to make a typo. I don't want to be wrong when I call what I want. So when I want to cast a spell, I will no longer need to pass it an instance of a spell. I will need to pass instead a type of spell, a spell name. Similar but not quite. And for this reason, now this will be a dictionary, and spell name will be a key, and damage spell will be a value. So when I add a spell, the spell book, I will add it based on its name. Yeah, its name. So the second thing will be the name. So spellbook, I add this, and now var spell, I get the spell. Spell name, I'll rename this to, and my spell is being gotten from a spell book based on spell name. And now I can work like I did before. So if I go back, we add those spells. Scorching Ray. I could have added a spell name inside the spell itself, but I won't go too deep into design. For this lesson, it's just the concepts and basics. So now I need a target, so my target is dummy, and the spell I want to use it for it is Scorching Ray. And here I didn't need that. If I go to logger, I'll move this logger. I would like to. It's a console logger, so CV and text. And one more thing: when our target dies, it will keep dying when damage reaches 0. So it should have a flag indicating if it's dead or not, so that I don't keep killing it every time. So if HP goes under 0, is dead is true, and I won't call this anymore if it's already dead. So if it's not dead already and HP is under 0, I kill it. And is dead should be in here. So now if I go back to my console uh, and if I run this, so our target has 10 HP and our Scorching Ray does 10 damage. So when I run the application, which is console, I should get the output which prints dead to console. It terminated immediately because I didn't stop it. Read line. This is a bit problematic because I have crappy namespaces, as you can see. Never name it like this. Never ever ever name it like this. Console is just the worst name you can pick for a namespace, for an assembly name. It's the worst, so don't do it. Why do I have this? I don't know. Console. Yes, please. So console, now this keyword is no longer reserved and I can use it. So console.readline, and we will stop the execution. So if I hit Ctrl F5, nothing happened. Why not? We took a spell from a spell book. Right, mana. Our caster, how much mana does our caster have? Well, not enough, and we can print that. Logger, log, not enough mana, and the mana I need is, I'll print that out here. The mana I need is mana minus spell cost minus. Alright, so if I hit Ctrl F5 now, not enough mana, 10 mana needed. And this is because I didn't set initial mana for the spellcaster. So when I create a spellcaster, I should be able to say how much mana it has initially. And now I'll set it. So if I go back to caster, I'll give it 10 mana. And if I hit Ctrl F5 now, nothing happened. Why nothing happened? I don't know. Right, we have our target, and we said that if target is not dead, so both conditions need to be true. So if HP is less than 0 after he took damage and target is not dead already, we kill it. By default, this will be false. So it should have been called, I think. Let's see what happens. So HP is 0. Oh, right. So if HP is 0 or equal, we kill it. So we say that the target is dead. And that's about all I wanted to show for this lesson. To introduce the principles of object-oriented programming, half of the principles, which is abstraction and encapsulation, that we exposed are fields through properties, that we abstracted away our details, that we exposed all that was needed, but not more than we needed. So that's it about this lesson. Does anyone have any questions? Then I guess that's it for today. Uh, Thank you for watching and bye bye.